Okay, let's start.
Come closer a little bit is okay. Even blocking a bit is okay. The intention also, they want to have some participants. So this is the actual part of the wellhead. So really, what we talk about, we have a conductor in place first. Then we start install our wellhead, build pressure beacon. So this is actually really the conductor. So we power this conductor in place already. Then we cut it with the bevel. So we highlight a little bit, but this is square, really square piece. We don't have any bevel. Our actual equipment, we actually always cast the bevel. So when we install the seal, it doesn't get cut, it doesn't damage. So this is actually the slicks, you can see. Slick, they have teeth. So if you see really on this is actually the teeth direction. The teeth direction will be a certain degree facing up. That's how it's holding the whole wellhead. If you have a pressure to push hold things up, it will actually hold it. That's how actually the teeth facing up. So liner hanger, all these mechanical mechanism, you can see in a lot of competition equipment, the hardware and all this. They are all after certain all these held down, retentions and all these hanging. So that's how it splits. So what they use to activate is this one. They have this lock screw. The yesterday model is actually having a start here. So what happened is a start, but they have two segments here, two pieces of ring, and that ring will actually push the sleeves up with the back using. So at this one actually is this lock screw. So with this lock screw, so we already install our wellhead casing first wellhead. So then we can paper up the risers and divertors or even POP. So like what I said, most of the time number one is diverter. But in every single well, the casing architect, the casing requirement might be different, and the pressure that we need to use to drill to the TV might be different as well. We do actually have cases we don't need diverter. We use a POP. But we also have cases that we use POP, but we put a requirement that you cannot shut down. Because when you shut down at the surface casing section, you actually will crack the shoe. So, but to be convenient, we use POP because you don't need to change the once. So all this strategy, how we understand the equipment is important. For us as a wells engineer to make vision what we use the more optimized is it, the better operation time. So nowadays, sometimes you meet a lot of people in this industry. They say, last time I do this, but I always quite against them. Because to me, last time you do a wells exploration well, maybe 60 days. You have a lot of problems. You use the base one, you probably have losses, you have stuck pipe, whatever issue. But now the operation is become more performance drive. We might actually do a wells in 20 days for explorations. So the drive needs to be there. So that's what planning become more and more important. Because a lot of last minute changes, when you know the things too late, you just couldn't get it. When you couldn't design this upfront 6 months, let's say 1 month before you ask the rig, I need a diverter, which you never planned, they might not able to get it. So by understanding all this, allow quick plan and also they secure the projects. At the end of the day, it's about time to do the wells and also the rig exercise. So we establish a riser. Without this component first, we're just looking at this casing. So we do the next surface casing. So this is just estimate this will be the presuming this is 13.38. So it's 13.38. This is normally 9.58, then there's the clipping. So 13.38, we can drill 7.5 or 16-inch hole. So whichever hole, we normally will compare the qualities. But 16-inch hole versus 70.5 is always on long grading, because some actually say it's better with 16-inch, some say better with 70.5. In details, I might need to do the study on the particular ways. So after reach a TD, then we pull out the bit. Then normally it's a must. Before we run the casing, we must remove the wet bushing. So why we must? Wet bushing is to protect the sealing area. So why we must remove?
So we can see it.
Because it's actually the same position where the casing is landed. So without removing this will be actually wet bushing when we drill. Without removing this, you can't land a casing anymore. But imagine, you already remove the wet bushing when you already run casing 1,000 feet to the downhole. Then you're screwed up. You actually basically have to remove this casing back. You need to remove the whole thing back to surface 1,000 feet. You need to break every connection, only fit the joint. So that's incur a lot of time. That's one of the most ugly things if we are drilling engineers. So you remove the wet bushing, then we prepare to run the casing. Then you run the casing all the way to the bottom, then we have the casing hanger. So this is manual hanger, ready? And it's a fluted type. So you can see this slot. So when this slot, you can see against the wellhead, then that's where the flow comes from. So you are taking the returns through this slot to the which we call flow line. So you will flow all the way to the diverter, above the diverter, in between the diverter and the rotary table we have so the nipple have something like that. That's to flow whatever returns through the trackers and levers. So that's how it is after the casing hanger. By that time we couldn't test because this is a fluted type. But after we landed, then we do our cementing job. After cementing, then we'll set this back off. So before we set this back off, because a lot of times there are some debris, they will run a specific wash tool. Wash tool is quite straightforward. It's just jetting. So the jetting will actually wash away all the dirt, debris, or whatever cutting maybe actually accumulate above this area. Right? So after washing, then only we set it back off. So after we set the back off, we can test it. What happened is back off test fail.
Back off fail.
Yes.
Not
everything, just the
back off.
So that's the benefit with back off and the hanger separate. If I have a hangers come with seals, I landed, I must test it before cementing. That's but after cementing sometimes it's still active. So after cementing we'll do another test. But at that stage, if it leaks, I have to pull the whole casing. Casing already cemented. So definitely then we have to evaluate what's the forum plan. Are we going to pull? There will be a forum discussion with everybody. Are we going to pull? What we can do else. So at that mode, sometimes we might try sealants. It's leak, but maybe it's minor leak. We have to look at the leak rate also to evaluate whichever solution is planning more benefit operations time. So that's how we set the back off. Then with that, we have cemented soon, we have everything. If all this as a barrier, if we take the barrier requirement, then we will remove the risers and carpenter. So after we remove, then we put this compact wellhead. So this wellhead, you can see is actually compact. Somehow you might actually see two spools like that. But this is a compact wellhead that they pre-make up together. So you don't make up this, you make up this onshore.
So just tighten it.
Yeah, just a main part of the manufacturing that they bring. Make up this, so this hole is the upper and lower compact wellhead. Sometimes to be exact, is the upper and lower where they make up together. Okay. So we nipple up this, then we also nipple up the risers and BOP tank. So that's the giver again, the pressure containment. Emphasize about function of wellhead, pressure containment, seals hanging the hanging the CTT, the casing straight. So after we do this is all first nipple up, so we don't have this. So we go ahead, before we drill, what should we do? Yeah, what should we do? Before we drill.
Clean up?
First, we run the test plug.
Test
So,
to
we
test
nipple
the
up, and then we must test the connection.
okay.
It may not be a full BOP stack test like what you mentioned.
Yeah.
It's not the full RAM
The
test,
cup.
but at least the connections.
The
But if
If you
the
set
test plug will be sitting here, right? So when it sit here, it's testing all the connections that you have all the way to the BOP.
above.
If we have done the BOP RAM offline, then we just do connection test. But if unfortunately we couldn't do it offline, then we need to do RAM test at that stage also. So with that, then we finish test plug. What we need to run is the wellhead test. It's for picking up the beat.
Run before
This is empty now, right? So this is empty. So what's the next piece of tools we require? We're pushing. So we're pushing and ball protector, they are all things the same thing. It's just different. So it's empty now. We run in and we pushing, which protect one is used. Then we run a bit.
Ball protector still like a different.
same.
It's the same. What I say, the description sometimes varies. Then sometimes like subsea, then you might actually see different name and all these circuitry, isolation tools and all this. Some might actually, we just need to understand that tools is allow us to do what. Okay. Definitely, we cannot cement up again because then you can say the takeoff price. So it is definitely below the hanging point. So below the hanging point, either we want to top up all the way to here, or below, sometimes depends on simulation also. And sometimes when you do the simulation, you might not have enough ECD. So you might not able to get the surface. But really this between conductor and the first surface casing, we're trying to cement the surface as much as we can. But certain things we don't do that. Might also associate with the platform design. But most of the platform is still okay, we can cement this. But if we have losses or whatever tell us cannot reach, we might actually plan to the seabed.
So for each piece, bukan
This is the highest point you can get. It is the highest point you can get.
I can go as high as that.
But this is really for first annulus EPT. The next one, we have vertical holes. It normally just above the last casing issue.
This bump,
This annulus. Which sometimes, obviously, you will see if we cement the surface, because this annulus, that's why some old wellhead, you see, they don't have this one also. It's just blank because they have the surface, cement the surface. But this section, how to get, actually whether you get the cement return to surface is always uncertain. Because volume at the big hole is always uncertain. You might get wash out, you pump 200 SS, but you still cannot get a cement return.
so all, let's say all the connector using test, I only have a test. So if I cement, you talk, I will see the cement come out.
So what we will do is we will check from the return line. We will use the phenolphthalein to check whether the cement is
Return.
It's just a verification. Minimum ID is here. Where the most smallest ID. So your bit will be running through this one.
So big will be smaller than. So the minimum ID is the smallest ID, right?
Ball?
Ball ID?
Ball ID is typically detected by the nominal size, what we always call like 13.5. So 13.5 is always the nominal ball ID. It can be plus minus a little bit, but it is really this one where your hangers and the type of your seal against.
So ball or minimum ID is smaller? Smaller in ID. Minimum. Okay.
So my pack off must be designed to be ball ID.
Pack off must be
Designed to the ball ID. But then my milling bit must be smaller
Minimum.
than my minimum ID.
Or whatever downhole.
Oh, whatever that was.
okay.
Okay. So then we talk about putting this compact wellhead into the test with test plug, and then we run the wet bushing, protect, wet drill. After we drill, then we run the casing, similar repeat process you can see. Then we run the casing. This is 958, you can see 958. Then we run through depth, then we cement. After cement, we wash the ring, then we set the back off. After this, what we're going to do? This is compact wellhead. So at that stage, what should we do?
Set back off. That's the back off.
That's the back off.
Okay, that's the back off.
Then what next?
Run the production. Yeah.
You don't need to put out your. That's a key for compact. So you minimize BOP time,
Rig operation.
second time. Then you still have to. We don't change anything. We don't need BOP test also because connection they are all verified already. Unless at the start, let's say post 21 days according to 53. If you have 53, then we need to do the test now. Just the full BOP test. If you know the well.
Working use for
The
21 days.
BOP on the well.
On the web.
BOP on the well.
So with that, then we still set another wave machine. And then we will set another wave machine a bit higher to protect the BB head. The previous one is long one, going from here all the way to the top, right?
Yeah.
Protect everything. But now this is already in place with the back off. So the next thing is we will actually set another shorter wave machine. That's where sometimes you see a long wave machine is scripted and also the short one. So the short one obviously is for the building angles. Then we set that wave bushing, we drill the neck hole section, then we run the tubing, then we run whatever lower to upper completion, complete the well. So after that, what should we do? Yeah. after tubing hanger, after landed, after we tested it's good.
Can nipple up with your
Not yet. What we have in the tubing hanger.
Plug.
or we need to retrieve the
Yes.
Retrieve
We need to
the
run the tubing hanger plug.
the plug.
So at that stage, typically your cement is not sufficient
Okay.
because it's hydrocarbon.
Okay.
Then you need two barriers. So
Okay,
with
okay,
hydrocarbon, you need two barriers. Then you must have
Plug in the-
plug, and then maybe whatever
TTT.
TRSB. So one more. I will prompt another question. Just continue this one. So we have the barrier. Then we can remove the riser BOB.
Yes.
Then we put on the tree.
Yes.
With the tree in place, so with the tree in place, how many barrier we can have? If I'm to enter a wells for intervention job,
3.
normally for intervention, they don't look at cement anymore. They don't look at whatever overbalance weight. All this fluid is not as a mechanical barrier. So well intervention, they only mechanical barrier. So packer is not really in the string. Packer is outside the string. So it's sealing the annulus end. So in your string, we have TRSB,
Yeah.
we have tubing hanger,
Mm.
and then valve on the tree. We have many.
The PC.
We have lower master valve, we have outer master valve. We can even use a crown valve.
Okay.
So those are the barrier.
Okay.
There are a lot of barrier, redundant, but it depends what intervention job you want to do. Let's say you are to repair the crown valve. Of course, you establish up to the lower and upper master valve. You already got two barriers.
Yes.
So you can straight away treat that as a barrier or even the TRSB, then you can repair your crown valve.
Over.
But if your lower master valve leak, then whatever
TRSB,
below only consider
plug.
barrier. So
Yeah.
you must set the tubing hanger plug.
Yeah. So now, one nipple up, up nicely. No, my plug.
Plug.
Then I put this screw. Then after that, I need to pull out the plug. Then if my lower valve is as a screw, I need to set another plug for the second way screw because I only have here.
Yeah.
Yeah. Need to
That's
barrier
for
lah.
intervention.
For hydrocarbon.
So we do need to understand a little bit the barrier we can use. Yeah.
What's the gauge for? Is that for the beginning?
No, this is just for another spray. This is not for. So PDG.
Done one.
I think we almost done with the lower second. Let's go up. Just
The control line is the non-continuous one.
control line. This is the continuous. So you can see it doesn't stop here. This line go up. So it is a continuous control line.
Okay.
So if I have a conventional one, which is not compact, I will have another one smaller. The robot is still the smaller. But because it's compact, it's only one size. Set one.
So what you can see now, this compact valve, there are only one minimum ID
Yeah.
here. Body
For two whole section.
for two holes. So this is, for example, 12 and 120. Now you need to drill 12 holes. Then you can drill 8.5 without any issue. So with that, if it's conventional, it's only one. You will stop here lah. With that, then the next tubing head normally you have another stack there.
And then you will.
Okay. Let's go up, then we can.
Boleh?